For the situations where you'd want to get a result back, you would rely on your own delegates that we looked at in the previous module. That's not a scenario suitable for events. Here's another important thing to remember. OnOrderCreated is a normal method call. In its turn, it invokes the delegate OrderCreated, which happens to be declared using the event keyword. That means it can only be invoked from within this class. When the delegate is invoked, all the subscribers of this event will be sequentially executed, one at a time. Just like one method call at a time. This is important because if you have a subscriber that takes a lot of time processing the event, this would make the entire order processing slower. Just like if you had a slow method running inside the order processor, we can easily visualize how this works. Head over to the program. This is where we are going to set up our event handlers. Any class that has a reference to the order processor could attach an event handler to the events. I can't stress this enough. If a class acts as a subscriber and attaches an event handler to your publisher, it is extremely important that it also unsubscribes from those events when the class is no longer being used. We'll dig into this a little bit more later on in the module. But for now, please keep in mind that whenever you subscribe to an event, you should always be unsubscribing at an appropriate time. You'll see the publicly exposed events on the order processor instance. In Visual Studio, this is highlighted using the Thunderbolt icon. Whenever you see this, you know that you have an event. This allows you to add or remove delegates from the invocation list. All you have to do, just as we've explored plenty of times now, is to reference a method that corresponds with the signature. To visualize how the handles are invoked, I'm going to add 3 event handlers expressed using lambdas. The lambda is created by defining the required parameters, which is the sender and the arguments. We can construct a lambda that first simulates a bit of processing by using a thread.sleep for 1 second, then print a number to the console. Let's do this 3 times. These anonymous methods correspond with the event handler delegate, and event handler is just what these methods are normally called. The program is now our subscriber and has 3 different handlers added to the order processor. Before you run the application, what do you think is going to happen? Will all these event handlers be executed simultaneously? Which one will be executed first? What happens to the rest of the execution in the order processor? Let's run the application to find out. After the order has been initialized and the event is raised by the publisher, this invokes the first handler, which takes 1 second to complete. When that is done, it proceeds to run the second one. After that is done, it runs the third. After all of the event handlers have completed their processing, the order processor proceeds to execute the rest of the code. This is simply because each event handler is executed sequentially in the order they were added. A publisher may have multiple different events defined. This is something you will see a lot, especially if you work in UI applications. With events, the publisher owns the invocation, And also, the events should be using a delegate that conforms with the guidelines. Another important aspect is that in most applications, the associated event handler and the subscriber will be attached and subscribing to that event for a long period of time. In particular, you will see that more often in UI applications. Now that you've seen how to create an event and how it's different from a delegate, let's proceed to learn about event data and how that is passed into your event.